Hello, my dear students. So, here is our question of the day, day 2. Topic that I have chosen is work power energy. This question I have taken from Pathfinder. Challenge your understanding, question number 1, right? Specialty of the question I already written. So, it is the first time that this question is coming on any online platform, right? So, means including YouTube, many teachers are running their apps, websites, right? So solution of this question is not present till now on any online platform. So now my students already know my nature. So it's not like I'm trying to say only I can solve this question, right, beta? So it is just like this question till now not available on any source. Means many of my students already have checked. So this solution of this question is not present on YouTube, on many popular apps also, websites also, it is not present. Okay, buddy? So let's see, let's try to learn what is the special thing behind this question, right? And understand it properly. Okay, so dear students, so here is a question in front of you, right? So read this question properly. One thing that is, I think, should be mentioned here. So this is the ring, and the ring is in horizontal plane. So maybe some x y axis they have shown it here. That is x y, and they are trying to say positive z axis is vertically upwards, right? But yes, clarity should be there. Okay. So it is in a horizontal platform, and you are releasing this system. So in this system, what we have, two beads connected by a rod, and these two beads are connected further by strings, and these strings are elastic in nature, and it is in a condition of stable or unstable equilibrium, you can say, because if you displace it aside, so then what will happen, this angle is going to decrease, and this angle will decrease, sorry, and this angle will increase. So obviously along the displacement, the rod with masses experience force, and it will gain velocity in the subsequent motion. Okay, so now read this question properly, bete. Give yourself at least 4 to 5 minutes, or you can even think or for around 10 minutes also, not a problem, because it's a good question, and then we can discuss its detailed solution, right? Okay, so as I already described the question, that what is going to happen, the system will start its motion from the shown position, and will move at what point we want acceleration of point P. So first of all, what is point P? Point P is intersection of these elastic strings BD and AC, right? That is our point P. So now this point P, how it is moving? First of all, our approach is very much clear, that we have to apply what, work energy theorem, right? So work energy theorem we have to apply in this question, because already initially there is some energy stored in the strings. That energy is going to convert into kinetic energy of the point masses, right? So that is the thing. Now our brainstorming angle should be that how point P is moving, means what is the locus of point P, so that intersection point, how it is moving. So that should be our brainstorming angle. We'll try to obtain equation of point P. Okay, yes. So first I already explained what is the brainstorming angle here. So how I am trying to obtain equation of point P, that is one method I have shown here. There can be some easier method also, right? But what is coming in my mind, that I have shown to you. So that point D C, right? What I am writing, beta? I am writing coordinates of point D, coordinates of point C. That I am writing. I am considering this point as origin, 0 comma 0. This I am considering as origin. Now with this as origin, I will write coordinate of point B and A. So I am writing coordinates of point B and A. So coordinate of point B will be what, beta? It should be r cos theta, comma r sine theta, right? So now according to the dimensions given, length AB is given as r root 2. So then obviously this angle will be 90. So the total angle will be 90 plus theta. So if OB is forming theta angle with horizontal, then OA should form 90 plus theta angle with the horizontal. So like coordinates of B I am writing, similarly coordinates of A also I can write. So r cos 90 plus theta comma r sin 90 plus theta. So I am getting coordinates of A, that are coordinates of A, right? So now I can write equation of line BD, right, and equation of line AC. Then our point of intersection is a common point on line BD and AC, right? So first I'm obtaining equation of line BD. So by coordinate method, I am writing equation of line BD. So y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. That equation I'm using, beta. Okay. Similarly, equation of line AC I'm writing. Right. So by coordinates only, with the use of coordinates I'm writing equation of line AC. Now rearranging them. So equation 1 multiplied by 2 I am rearranging. After rearranging, what I am getting? I am getting equation of a circle. So I am getting equation of a circle. It means point P, that intersection point, will move in a circle with radius r by root 2 and center 0 comma minus r by root 2. So that is what, beta? The locus of point of intersection, right? Center and r by root 2. Now let's see what is required in the question. So in the question, what they are asking, beta, this acceleration of point P when immediately before a chord becomes relaxed. So natural length is given, so relaxed length is given r root 2, right? So now let's see now D. So that is our elastic string initially already. So there is length 2r, and now final length should be r root 2. It means B point should come here, right? B point should come here and A point should come here, beta. So it means it should be like this. So I have drawn the diagram also, I think. Yes, I have drawn. So the position will be like this, beta. So that is the one string in dotted I have shown, and that is another string. Okay, so that will be the shown position. So at this position, we need acceleration of point of intersection, which is what? This point, this common point B or C only, right? So acceleration of this point is required. Already we have obtained this point P is moving on a circle. Now let's say velocity of this point of intersection is V, which is velocity of point B or C, right? So now V, velocity of V, this angle is 45 degree. So if I want to write angular velocity of this point P, so then it is a component of a velocity normal to its radius V by root 2 divided by that length r by root 2. So that is what, beta? Angular velocity is V by r. So it means acceleration of point P should be omega square r by root 2. Why? Because when strings are relaxed, it means force, net force on each and every point of the rod is 0. So acceleration is 0. Okay. So what acceleration? Tangential acceleration is 0. So tangential acceleration is 0. So only what we will have? Centripetal acceleration, which is towards the center. Okay, so centripetal acceleration is omega square r by root 2, right? Now omega we can find very easily by work energy theorem. Total potential energy stored in the spring will convert into kinetic energy of the point masses. So initially length of both the strings 2r, and finally length of both the strings is r root 2. So change in potential energy is equal to kinetic energy. So from here we are getting V by r, right? So V by r we are getting. So it means acceleration of point P is what, beta? Omega square means V by r whole square into r by root 2. Okay. So by this what we are getting? Acceleration of point P. So obviously along circle, in a circle, centripetal acceleration is directed towards the center. So direction is minus I cap. So that is our answer, beta. Okay. So see each and every step in the solution. Okay. And then any doubt if you have, please write in the comment section. Okay. Thank you, beta.